When students get stuck choosing between the binomial and the normal distribution, the problem is almost never the formula. It's not knowing what kind of random variable they're dealing with. So start there. Ask one question first. Are we counting something or are we measuring something? The binomial distribution is about counting. It answers questions like, how many successes occurred? You are counting how many times something happened out of a fixed number of trials. Each trial has only two outcomes, usually called success and failure. The number of trials is fixed in advance. The trials are independent, and the probability of success stays the same every time. If all of that is true, then the random variable is binomial. You are not measuring size, weight, or time, you are counting successes. For example, the number of heads in 20 coin flips, the number of defective items in a batch of 50, the number of people who click an ad out of 10,000 visitors. In every case, the answer can only be whole numbers from 0 up to n. That discreteness is key. A binomial random variable jumps in steps. It never takes on values in between. The normal distribution is completely different. It is about measurement. It models continuous values, things that live on a scale rather than a count. Heights, test scores, measurement error, reaction time, these variables can take on any value in a range, not just whole numbers. The normal distribution is symmetric, bell-shaped, and described entirely by its mean and standard deviation. The reason the normal distribution shows up everywhere is not magic. It's because many measurements are influenced by lots of small, independent effects added together. When you add many small effects, the result tends to look normal. That's the intuition behind why averages and totals often follow a normal shape. Now here's where confusion starts. A binomial distribution, when the number of trials is large and the probability of success is not extreme, starts to look bell-shaped. In that case, the binomial can be approximated by a normal distribution. This does not mean it stops being binomial. The data-generating process is still counting successes. We are just using the normal curve as a shortcut. The rule of thumb is simple. If n times p is at least 10, and n times 1 minus p is also at least 10, the binomial distribution is not too skewed. Its shape is close enough to normal that the approximation works well. The mean becomes np, the variance becomes np times 1 minus p. But there is a catch. The binomial is discrete, the normal is continuous. To bridge that gap, we use the continuity correction. Conceptually, each whole number count gets treated as a bar of width 1. To capture the entire bar, you shift your cutoff by half a unit. So if you want the probability that x is less than or equal to k, you use the normal probability that y is less than k plus 0.5. That half unit matters, especially near the tails. So, how do you decide in practice? Think like this. First, is the variable a count of successes out of a fixed number of trials? If not, stop. It's not binomial. If yes, check the conditions. 2 outcomes per trial, independence, constant probability. If any of those fail, binomial may not be appropriate. If they hold, binomial is the correct model. Then ask one more question. Is n large enough and is p not too close to 0 or 1? If yes, you are allowed to approximate with a normal distribution. If not, use the exact binomial. If instead the variable is a measurement, something continuous like height, time, or error, then binomial is the wrong tool from the start. If the data are roughly symmetric and bell-shaped, or if you are working with averages of many observations, the normal distribution is usually appropriate. One last point that ties everything together. If x is binomial, the sample proportion x over n is approximately normal for large n. That is why normal distributions appear in confidence intervals and hypothesis tests for proportions. The binomial is underneath, but the normal shows up on top once the sample is large. So, here is the rule to remember. Binomial is for counting successes in fixed yes or no trials. Normal is for measuring continuous values, or for approximating binomial counts when n is large and the distribution is not skewed. If you always start by asking what is being counted or measured, the choice becomes clear.